Build specs from a different perspective. Today we're answering another subscriber question. B-Man asked a question on the Asus Republica Gamers Maximus Z690 Hero that has Thunderbolt 4. And his question, if you say you wouldn't build on a Z690 chipset, you're basically saying don't get an Intel 12th generation CPU then, right? Correct. Because another strong reason to build on the Z690 chipset is to get the new Alder Lake CPU. Also, what do you think of getting the Z690 DDR4 motherboards since PCI Express 5 and DDR5 is so unreasonable now? That way you get the Alder Lake upgrade. I've seen many results where the i9-12900K is really terrible. Okay, that's a great question. That's a lot of information, and I've had several. I'm actually trying to answer about probably 6 questions with this one video. And the title of this video is we're going to take a look at 3 16-core CPUs. And the reason for that is the information that he's asking about. Our goal is to build a purpose-built computer. We have an intention. What do we mean by that? Well, by what we talk about. We've identified 4 different levels of computer builds. Number 1 is an entry level. Now, the first CPU that he mentioned was the 11900K. Okay, I believe that's an 8-core CPU. An 8-core CPU would be an entry level, 8 to 10 cores. Why build a computer when you can buy a laptop? Okay, for this Z690 chipset, and I want to interject, some new information has come to light that Intel has now announced all their 600 series, and everything with the 600 series to me is a wash. Don't get caught up in the hype. Let's look at this from our perspective on how we build that machine so everything works together. Because my next question to him then was, then what are you going to use this computer build for? And we'll get into that in a minute, because we need to look at what Z690 is all about, and that's PCI Express 5. Okay, PCI Express 5 delivers 3 things, but I don't see we get any improvements with those 3 things. Number 1, it's about DDR5 memory. I don't see anything in the specs as it relates to content creation that deals with the speed of RAM. It's all about the quantity of RAM. Number 2 is about a GPU that's supposed to be faster. Well, again, the specs talk about video RAM. They don't talk about the speed of the GPU. And PCI Express used to be about the GPU, but now PCI Express is about the M.2 NVMe drive. And that is the one thing that we're the most excited about. Okay, PCI Express 5.0 on the Z690 chipset on some motherboards is going to be able to give one M.2 drive at 15,000 megabytes. We can do that on PCI Express 4 with 4 drives in RAID, as we talked about this machine. And this is the high-end desktop. So an entry-level machine, a secondary, which is 16 cores, and we're going to look at 3. So I want to get you up to speed, because where we're going with this is the WRX80. Now, we've been an advocate of the TRX40 for these resources, because we have 2 16-lane slots and we have 2 8-lane slots, and we have 2 M.2 drives that are to the CPU. We have 2 more M.2 drives that are through the chipset. We have all dedicated resources. And on each side, I've never mentioned it before, but I should, we have quad channel memory. And when you look at a system that has shared resources like he's talking about versus a system with dedicated resources, to build a purpose-built computer, the entry-level machine, I had a chance to spec another machine for a client in Germany, and that was quite an experience. First she sent me, I said, what do you have access to? She said Fujitsu. I went through everything I could find with Fujitsu, and that was Then I said, do you have access to anything else? Then she came up with a Dell, and I thought, oh, well, here we go. But I found a Dell for her that she could get in Germany that's got the specs of a workstation that'll blow everything else away, and she'll be pleased with the performance, and that's going to be a computer that should last her 5 to 7 years. Okay. As we talk about laptops, there's things you have to allow for. But as we talk about a desktop, there's things you need to be ready to grow for. And as we look at these specs on the Z690, that is a limited machine. You're on the level of a gaming machine. We don't build gaming machines. And another question came up from another subscriber. Well, what's the difference in a gaming machine versus a digital audio workstation? Well, big time, dedicated resources versus shared resources. And I kind of want to get into some of that, because anybody that's going to be building a computer for work needs to be either building a workstation or a high-end desktop. And because of some things Max has said, I've come to realize, and I didn't know this till I started checking again, I was going to put up some information to have 5 different processors. Okay, we're only going to have 3. 2 of those processors were on the X399 high-end desktop. Okay, the high-end desktop now on PCI Express 4.0 is on this machine with the TRX40. Okay, motherboards are now shown still listed but not available, not discontinued, but just not available. And the motherboards that are available, there's only one that has Thunderbolt. Okay, all the computers with all the chipsets that we look at, that's one of my prerequisites. I want to find Thunderbolt. I don't care if it's Thunderbolt 3 or Thunderbolt 4, because remember, Thunderbolt does three things. Power delivery, not a fan of that. Number two, video, and we may do some more of this later about video with Thunderbolt, but I don't get the point of routing video through Thunderbolt. Just take video from the video card and straight to the monitor. What's up with that? But number three is the one thing I'm a fan of, and that's data delivery. So this laptop that we spec'd, that is a workstation laptop from Dell, if I can remember, I'll find the specs, I'll get a link up so you guys can have reference to it. But anyway, that particular computer, I think, according to the specs from Dell, has Thunderbolt. According to the German specs, I don't sprechen Sie Deutsch, I know it's got USB-C, but I'm not sure about Thunderbolt. So if it's Thunderbolt on there, I told her, I said, look, what you want to do, either regardless of where those specs go, I would get a drive, an external drive for storage that can do both. If it can handle USB-C and if it can handle Thunderbolt. Now, I don't want to get into that. That's a separate video. But those are the two things I look for. The reason being, if she needs to connect to other computers to move that and migrate that data, USB-C would be the slowest thing I'd want to go with that. Now, as long as there's network access to the device, but that's another issue. I'm not a fan of NACE, but I've got another device I want to share with you that I just found out about that is pretty wicked for a Thunderbolt device. I will put the link up. I don't remember the name of it, but it's got like 8 Thunderbolt ports. I'm thinking, wow, that is a network device that you can plug multiple computers into to have access to that data. Okay, it's first coming out for the Mac. They're now doing beta for Windows and for Linux. I'll put a link up to it. But back to the specs we're talking about for 3 16-core CPUs. Again, to reiterate, I don't have 5 because those 2 on the X399 are PCI Express 3, and those 2 are discontinued. I said, wow. So if we go with the TRX 40, like this machine that we've been advocating, we've got to look at a 24-core CPU. Okay, to keep it all apples and apples, 16 core, 16 core, and 16 core. Let's outline some of the similarities and differences. And after we go through these things, I want to show you why we're going to end up with the WRX80. For the reason being, we're looking at something that is going to mesh together with the components with dedicated resources versus all those shared resources. You do this, you do that, you can't do that, you can't do this. That's crazy. You want dedicated resources. So if it's not the TRX 40, it's the WRX80. And based on the CPU, remember, your motherboard is the foundation of the computer. Your chipset is the foundation of the motherboard. But this time we're going at this through the CPU. So then my next comment and his comment, as I answered the question, and he answered my question, my requirements will be something like primarily 4K video editing of my GoPro footage, secondary gaming. Okay, to reiterate, we don't do gaming. And he says whenever I can get an RTX 3080 card. Okay, well, that's another issue that I think, as we've addressed and outlined, I've got 2 reasons right now why I can say you need to wait to build. 1 for the GPU and 2 for the CPU. But I'll get to that in another video, or I'll comment more in a minute. Let's go back to this. And I want it future-proof for 4 to 5 years. 4 to 5 years is pretty easy. I'd like to build now, but can easily be convinced to wait for a good reason. Thanks. I enjoy your in-depth channel. I'm still picking up on the jargon. If we say something that you don't understand, please ask. We learned a long time ago with BuildOrBuy when we used to do the live meetings. The only dumb question is the one you don't ask. Now, some of you have asked some pretty wild stuff and are doing some pretty wild things. I'll do my best to answer those questions as quickly as I can. But when I'm answering questions, it means I'm not doing video. And when I'm doing video, sometimes I have to hibernate so I can film it, so I can edit it, so I can get it up so you guys can see it. Okay, I have 2 reasons right now to say to wait. 1, to reiterate, the RTX 3090. That is a consumer GPU. Because you're looking at doing video, and that's what we're going to focus on, content creation, I would suggest, based on the resources, now we have an RTX 3080 Ti over here, but we've also got, in this machine, this is a temporary setup, we have an EVGA RTX 2080 Ti. This is 2 slots wide. It's crucial that your GPU be 2 slots wide or less. And as we look at the RTX 2080 Ti, it's like 3 1/4 slots wide. That's a problem. On a consumer gaming type computer, you got space because you don't have the resources. Let's look at the processors. Let's go through that. But for right now, for those that want the short answer, wait after the first of the year. all the stuff that's going on that's supposed to happen after the first year with the CPU and GPU, don't do anything in December, and don't think about anything, whatever they announce in January at CES. You're probably looking at March at the earliest. So if you can wait, I would wait. But if you want to go ahead, I'm going to tell you, and I'm going to sell you on the WRX 80. We've got a 16-core CPU. But let's go through the resources and see how this pans out. Because I always say change one thing changes everything. And the issue with the DAW, I'm going to come back to that a little bit later. In fact, I may make a separate video about that. I've been promising for quite some time, and I appreciate everybody's patience about the issues with the DAW. Because the question came up, have you ever built a DAW? What I need to do is find, to show you how long, to me that's the holy grail of building a perfect computer, is a computer for a DAW. I still have the original MIDI ISA card. Yeah, that's how far back, that's how long I've been pursuing that. Anybody remember the Ensoniq EPS 16 Turbo Plus? I'll leave it for that. I won't digress any further. But to build that kind of computer, that's one of the things I've been chasing ever since the beginning. So let's look at these three CPUs. I want to show you some stuff from PassMark. Now I've taken the liberty of putting these three CPUs up. The Intel i9-12900, which was the original question, an AMD Ryzen 9 5950, which is 16 cores, and the Threadripper PRO 3955. I never had really thought about this from the standpoint of a 16-core CPU, but after listening to Max, and then I had a comment from Shannon, who made a comment about a game, and I thought, what's up with that? But I appreciate what Shannon said, because I think his point was those specs for that game will work on a 10-year-old computer. Okay, I'm going to show you some stuff that we've talked about with slots as it relates to other things besides video cards or quad adapters. I don't want to call them RAID adapters, but quad adapters. RAID is another issue that we're going to address in a bigger way. But as it relates to a digital audio workstation, some of you may be interested in doing video capture. And we need to look at some of those cards and the resources they require, because 1080 is an easy place to be, and that's a good place to be, but I wouldn't necessarily get into 4K because of what they require. However, all those 1080 cards and 4K capture cards that sit inside a computer, all of those are PCI Express 2.0. That's kind of where the technology's at, because if somebody really wanted to do capturing, I wouldn't do it with an internal capture card. Blackmagic has a device, and if I remember, I'll put up a link to it. We might do a video about that later. But you know, a lot of this stuff, we need to set some baselines for some specs, and then step back and look at those specs and evaluate them and see, does this meet our needs? For example, on this 16-core issue of a CPU. Okay, what I want to focus on, we can look at the price. Now this says the i9-12900 is about $620, maybe so. The Ryzen 9 5950 is running about $750, and the 3955 Threadripper PRO is running about $1200. Okay, clock speed. I'm not interested in overclocking because we're not playing games, we're doing a work. So the base clock speed 3.2, 3.4, and 3.9. Now, I point this out because it's relevant for those that are doing CAD. Some have mentioned in CAD, because a lot of CAD programs are all about the CPU, but it's not about the quantity of CPU cores. It's all about the speed of the CPU cores. And all this stuff with audio rendering is kind of the same thing, because audio rendering is not multitasking. It's a single task project. I don't care how much of a whiz-bang computer you got. When you start processing audio, everything slows to a crawl. Where audio really benefits from is a lot of RAM. So the base clock, that's what we want to focus on, and not overclocking. Okay, number of physical cores, 16 cores, 24 threads. Okay, without getting into the details of how that plays out, to me, that looks more like what I'm going to call a hybrid processor. And I hope that's not something we're going to see us a lot more of. Now, why do I say that? Do y'all remember when Seagate came out with a hybrid hard drive, where you had a spinning hard drive and then you had that little bit of an SSD on the beginning of it that was supposed to make things faster? Those were really cool when they first came out, but after you used it for a couple of weeks, those things really sucked because the performance was abysmal. It did the exact opposite of what it was supposed to do. My concern, I'm not interested in a hybrid system like this. Now, granted, video cards are hard to come by. Granted, if you build that system from Intel, you have video on board, and I understand that. But for the performance of a machine that's going to be work related, I don't see that as a good bang for the buck. And we're going to be hearing more about these new APUs that are coming out, which is the kind of what that is. But from AMD, with the video built into the CPU, don't do those. The past generation we did about 8 years ago, and those things sucked. Stick with a straight CPU, stick with a straight GPU. And it reminds me, I saw an article that dealt with an application that escapes the name of it right now for rendering. I'm going to put some information out, if I can find the link, shouldn't be too hard, shouldn't be too difficult, that talked about they benefited most from rendering with a 3060 Ti. They benefited more from a 3060 Ti than they did from a 3080, which I found kind of phenomenal. But the one thing that I also got out of that was that that application benefits more from an NVIDIA GPU than it did from an AMD GPU. All the rendering I do right now, and I've said it a few times, but I haven't mentioned it enough, I render with an AMD GPU because CUDA cores are not an issue for what I'm doing. But as it relates to this, let's get back to these CPU cores. But I want to throw that out there. Okay, so we've looked at the CPU cores, and I like the fact that these are faster CPU cores. And again, we're straight CPUs, 16 cores, 32 threads. Okay, these first two CPUs have shared resources. This and the high-end desktop that I do not have listed are dedicated. I'm not worried about the wattage, and I'm not so concerned about the CPU mark. What I am concerned about, and this I'm going to take us into another link from B&H. Some of the information that I want to show and share is difficult to show collectively, such as what I showed here with CPU benchmark. It allowed us to put those three processors side by side, and it's easy to go in there, go to the master list and pull those out. But you got to remember, even though these are listed as high-end CPUs, a high-end CPU today is not going to be a high-end CPU tomorrow. So you want to build something with 4 to 5 years shelf life, so you need to build up. Now, used to, when we had PCI Express 2 and we built a machine 10 years ago, it was easy to identify a high-performance chipset. Okay, now because of these resources of shared versus dedicated, it's easy also, but you have to understand the difference in shared resources and dedicated. For example, on the i9-12900, we have 20 PCI Express lanes. Again, on the AMD Ryzen 9 5950, we have 20 PCI Express lanes. And I'm going to show you another chart that takes us into B&H that further breaks those lanes down on the 12900. Now, the piece de resistance is a Threadripper PRO 3955. And depending on how you count PCI Express lanes, you can take it for the facts according to the specs, which are 128. I'm going to be a little more conservative because you've got chipset to CPU connectivity, and that takes up 8 lanes. So those 8 lanes, we'll take those off the table. We'll call that 120 lanes. I'll come back to that. Now this link into B&H, I was able to achieve 4 links. I have a 2950 up here, and I want to start over here on the far right. That 2950, and there was also a 1950. Those are gone. Those processors are gone. And that was what really got me thinking about this when I started putting this together, that for us to cover the high-end desktop, we have to differentiate from X399 to TRX40. And the X399 PCI Express 3 is a great system. In fact, we've got one that has a BIOS update, and it's been about a year. I'm really curious if that machine that had the pinout for Thunderbolt 3 is going to have BIOS support. I don't know. I'm trying to decide whether to make a video about it and show you guys, but I'm not sure yet. But that's another one I digress on. But when I realized the 2950 and the 1950 are no longer available, I thought, what an eye-opener. Now I understand, because I hadn't been looking at this so much, of what Max was talking about, and this was an eye-opener. So the main reason for having this up there is for a comparison, because once you get past the sticker shock of the CPU, I'm going to show you a different way of looking at that CPU where, well, hold that thought. Okay, even this particular Threadripper PRO, this processor, right now is not available, but it's $1,200. What I want to get to down here are in the general specs. And looking over here at the i9-12900 on the left, what I like about this chart, this is the only place I've seen where it breaks out how those PCI Express lanes are running. 16 PCI Express 5.0 lanes and 4 PCI Express 4.0 lanes. But to reiterate, on some motherboards, you will get one M.2 drive on an add-in card that will support PCI Express 5, 15,000 megabytes. But we can do that speed on RAID with 4 drives. And as I stated before, let's take a look at RAID in terms of PCI Express 4.0 first generation, of which there are 3. So we're talking 5,000 megabytes per drive. Okay, RAID 0 would be the speed of 3 drives. So that's 5, 10, 15, 20. So you will get 5, 10, 15. 4 drives to get 15,000 megabytes, first generation. And that's the way to equal that in terms of speed. But we don't have shared resources that we have to monkey with and figure out who's on first. We've got dedicated resources. All we have to have is a 16-lane slot that we can bifurcate in the BIOS. Easy. And the next video, I'm going to talk about a purpose-built computer that we're looking at doing RAID for one purpose, a GRAID. And it's, as Joe would say, if I were building, this is what I would build. Another video. Now, this does not give on the Ryzen 9 5950 the lanes, but there's 20 PCI Express lanes. And here on the right, on the 2950, it shows 64 lanes, but they're PCI Express 3. Well, that's on that particular processor. But when we go to a 24-core processor, then we get PCI Express 4. Okay, we're sticking right now with 16 cores. And because, as to reiterate, 8 of those connect that chipset to the CPU. So anything that's through the CPU is connected to those 8 lanes. Based on these other 2 processors, you're going to have 4 lanes. With Intel, they call it DMI, 4 lanes connected. So anything through the chipset is through those 4 lanes. And with the 5950 from AMD, again, you got 4 lanes that connects anything from that chipset to the CPU. So anything that's going through that chipset is going through those 4 lanes. Just want to point that out. Another issue I want to point out is the issue with RAM. Now, I believe these will support 128 gigs of RAM unless you're looking at like the Mini ITX. Either one of these will support, I say either one of these, either the Intel i9-12900 or the AMD Ryzen 9 5950. Either one of those will support dual channel. Now, dual channel, and I wouldn't go with PCI Express 5.0 because I wouldn't go with DDR5. I would stick with the DDR4, but that's just me. But on the AMD Ryzen 5950 with PCI Express 4 dual channel, I want to point out, as some of you have mentioned, you've got 4 slots. You only want to use 2 slots for dual channel. When you use all 4 slots, you take a performance dive. So that's something to be aware of if you're going to build that. Now, another thing to be mindful of, if we go look at that processor with AMD on the 5950, that's a gaming processor. That's how that's marketed. That's how that's sold. Now remember, we looked at an ASUS ProArt B550 motherboard because for one reason, that was the first motherboard to have Thunderbolt 4 support for the AMD platform, and that's why we did it. Okay, there are others out now, but it's still a gaming processor. So you have to consider where you're at in the process. So, but I got another number I'm saving for you, and I'm going to give you an analogy like we used to use, and I hope this will give you a new perspective on how to look at this thing. I also wanted to show you PC part picker, but that only works on the Intel for the Z690. That works on the AMD, whichever chipset we choose for the 5950. It works for the TRX 40, but it doesn't work for the WRX 80. I wish they had that listed there, but I guess because it's Workstation, they don't and they won't. So the reason I mention it, I was looking at links I was going to provide to show you motherboard processor, motherboard processor, motherboard processor. And that's when it hit me on the TRX 40, the motherboards that are just, again, there to reiterate, not available, not discontinued, but just not available. And of about 4 or 5 motherboards I saw, none of the ones I saw were ones I'd want to get, and the one we advocate has Thunderbolt 3. And the question comes up, will the TRX 40 support Thunderbolt 4? Okay, the only difference in Thunderbolt 3 and Thunderbolt 4 is bidirectional. That's the only thing. Now, it's come to my attention, and I want to tell you right now about Thunderbolt. Gigabyte has a Titan Ridge Thunderbolt 3 Revision 1, we've talked extensively about, updated several of those. I had a chance the other day to work on the, I finally found it, the Revision 2. And some of you had mentioned this and I didn't realize, but the Revision 1 had a 5-pin header. The Revision 2 has a 5-pin header and a 3-pin header. Why is that significant? Okay, when Gigabyte went to Thunderbolt 4, they kept that 5-pin header and 3-pin header. Here's what I know. Revision 1, BIOS support. Revision 2, BIOS support with the Revision 2 card, only using the 5-pin header. Does that mean we can put Thunderbolt 4 in here and get motherboard support? I don't know, but I'm telling you what I know. It took about 2 hours to figure that, and I popped the cards in and out. I even did the hot wire and jumping it because I was going to show it. And after I was done, I didn't like the results, so I'm telling you what I found out. That's something still to be determined. But I cannot test Thunderbolt 4 in here without BIOS support because it has to be hot wired, jumping pins 3 to 5. And when I jump pins 3 to 5, the BIOS thinks it's connected, and it looks like it has BIOS support when it doesn't. So I need to be on another platform that doesn't have BIOS support so I can test my theory. But if it's the same, and all you have to do is jump pins 3 to 5, then it's like we had on the Gigabyte. I believe it was the Gigabyte X399 Aorus Extreme has a BIOS update. It's been about a year. And if there's BIOS support for that, instead of having partial support, that means we can have full support, which means we can allocate memory for the devices. Now, of the 3 things that Thunderbolt does, I'm only interested in one. That's data delivery. For those that want to do audio, we've still got a couple audio interfaces to look at. So that's something else that's a shadow of things to come. But as we look at this, let's step back a bit for a different perception and a different perspective. Because remember, the title of this video is 3 16-core CPUs. We looked at the Z690. We looked at the 5950. Both of those have shared resources. Both of those can support about 120 gigs of RAM. Both of those are dual channel, and you take a performance hit on the AMD 5950. If you use all 4 sticks, you only want to use 2. Okay. Those are both shared resources. Now we're looking at dedicated resources. When you go to dedicated resources with the high-end desktop or with the WRX80, the WRX80 is really the key place to be because there's supposed to be a new series of processor. Right now, Threadripper has gone through 3 versions. On the X399, version 1, version 2. And we didn't build until we hit the X399 with the second version. Then we built this machine on the TRX40, which is the 3rd version. My point, the WRX80 is a brand new platform. And there's still issues. People are having trouble with RAM. I just got an email from someone the other day. When we did the BIOS update on this Gigabyte TRX40 Designaire, they said they finally have memory stability. So I'm sorry I didn't do that video any sooner, but I'm glad you have memory stability. My point is, bleeding edge technology, there's issues. As we go to a WRX80, I would strongly encourage people to use ECC RAM because of the platform, because of what's going on. Now, the formula that I need to tell you about. Do you guys remember when we used to look at spinning hard drives? We did this all the time at the live meeting, but I'd kind of forgotten about it. But I got to thinking about it when I did this, and it kind of was an eye-opener to me, and that's why I want to share it with you. Okay, how do you price out the price of a hard drive? You can look at what the price of the drive is. You can see the capacity. But the true price of the price of a hard drive is the price per megabyte. For those of you that see where I'm going, what does a CPU cost based on PCI Express lanes? Kind of interesting thought, right? Let's take a look. Let's just do some quick math. If I have a $600 processor and I'm going to divide that by, say, 20 PCI Express lanes, that's costing me $30 a lane. Okay? If I have a $750 processor and I divide that by 20 PCI Express lanes, that's costing me $37.50 a lane. Okay? If I have a processor that costs me $1,200 and I divide that by 120 PCI Express lanes, that's costing me $10 a lane. So how do you like them apples? When I saw that and thought about that, I thought I wanted to share that with you guys, but I wanted to give you something to think about. If we do that same analogy, that is not an expensive processor for dedicated resources. The question becomes, once you accept the platform, which motherboard do you want? Now, right now, we know of 2 motherboards that will support Thunderbolt. One is available. The other one is a preliminary. That's the one from ASRock. It's ATX, and I think if ASRock will ever get their britches together and get that thing in the market, I think they'll be overwhelmed with sales. The question is going to be which processor. If you're doing CAD and you're processor intensive on the speed of the cores, that 16 core looks like a good place to be. As far as the GPU, I got some stuff I want to share with you in the next system that I'm looking to build because I need 5, 6, 16 lane slots, and I'd like to have Thunderbolt 4 because it's going to be for a GRAID. So I want to thank you guys for watching. This is BuildOrBuy. My name is Gil Boyd. We're on to the next video. We're out.